In this video, we'll do two practicals. You can see here, already discussed half-wave rectifier and full-wave rectifier. These two circuits we will do it. So I will just I will tell you how to do it on a breadboard, and we will check the voltages and everything, and I will give you the complete explanation. So I will just go to this. All right, now you can see I have used a breadboard, two diodes, one filter capacitor, one LED, two resistor. One resistor is of higher value, this one. That is, we call it as a load resistor, and this is for the LED in series. You have using one transformer here. We are using one transformer, a step-down transformer. How to give the connection, you please see. For first of all, we'll make a half-wave rectifier. So for that, we'll need only one diode. Only one diode. Okay, only one diode we'll need. So I will just start with the diodes. Already I have given two connections here. So what I will do is I will just give this two connection here. I will give one negative to the transformer here, and one another end of the transformer which is coming from the transformer I have connected it here. So according to the circuits, you just first what you will do, you will check which is anode and which is cathode of the diode. So first what you will do, anode of the diode, you will connect to this end, That is, I will just connect it here. Anode of this one I'm connected here. So anode goes to AC here, cathode goes to another side. So what I will do is I will just connect one resistor, that is dropping resistor of lesser value for the LED purpose. Okay, I'm just giving it here. I hope you all know about the breadboard connection, right? This breadboard connection, these are vertical and these are horizontal connection. These are vertical. So the maximum we'll use the vertical connection side only. Okay. Now, as it is given, I will use one electrolytic capacitor. The negative will go to this end, this side. Okay. So I will just connect the positive end to the cathode side. I have connected it to the cathode side. I have just connected it to the negative side, but I didn't connect the complete these thing. Okay. So what I will do is I will take a jumper wire, few of the jumper wire. I will just connect it from here to this place. Okay. Right. So negative to the transformer, another end. This is the another end of the transformer. Okay. Right. So what I will do is I will just connect the LED now. LED. So LED again, you should know the anode and the cathode. The positive is the lengthier one, and then the smaller end is a negative one. So positive, and I will just put it to the resistor another end, and I will just connect it like this. Okay. Oh, now what I will do, I will again this end, this another end, that is negative end, it has to go to the negative. So I will just connect this from here, and I will just put it to the negative line. This complete line is negative line. Please remember, this is all negative line. This complete line. Okay. So I've given the connection. Now what I will do is this thing is over, but I have to connect one load resistor also. So what I will do is load resistor, I will just connect across the positive and the negative of the capacitor. Okay. So I will do one thing. I will just connect one end to this thing and another end to the positive of the resistor. Now let's see, giving the connection, what happens to the LED. I will just try to connect it, the transformer. Now LED has come. That means the transformer, from transformer you are getting AC. Let's check the AC. I have kept it on AC on multimeter 200 volts, and let's just test the AC first, which is coming from the transformer. What is the AC? How much it is coming? We'll just check. So I will just put it on the negative side. So this is approximately 9.5 volts AC. Okay, right. So we are getting transformer from transformer 9.5 volts. Now what I will do is I will put it DC. Please remember to every time when you are checking AC, you should put on AC on this side. When you are checking DC, you should check on this side. So 9.4. So I will just put it on 20. Okay, DC. Okay. Now I will check the DC. That is rectification after the diode. This is the diode. Please remember, this is the diode. This diode. AC is given here. DC is given here. So I will just put the negative on one side. This is my negative side, and this is positive side. Okay. So how much it is coming? 12.54. Okay. 12.54. So my DC after rectification, it is 12.54. Okay. How much was the AC? Approximately 9 point this, and 9.4 and 9.5 was. And this is the dropping voltage which is going to the LED 1.89. Why? Because my LED is red color LED. It is only, I cannot provide more than 2.6 or 2.7 volts. If you give more voltage, that's why I've used this resistor over here. And this is my dropping resistor. Okay. For the protecting the capacitor, that is when it is fully charged, it should get discharged immediately. That's why we use the load resistor. All right. Now what I will do is I will make one circuit that is all right. Now we'll go for this was previously we saw half a rectifier, only one diode. Now what I will do is I will use one more diode, that is full wave rectifier. Already I have given you the circuits. I've shown you the circuit. So before that I will just tell you what I did. So I have used all the three wires which are coming out from the secondary side of the transformer. The center wire, this is the center wire, center tap transformer. So I have the center tap wire. I will just do one thing. I will center tap wire. I will connect it to 0. This is the 0. Okay. I have connected to 0. One end I have connected, already I have connected to this LED, and one more LED I have to connect. So what I will do is I will take another line just adjacent to the previous diode, and I will take this diode. I will check which one is the anode and cathode. So anode side will go to AC and cathode side will go to the another side. Okay, so I will just do one thing. I will just connect it here. The another side, that means I have connected AC over here and another side DC, that is cathode side, together to previously where it was connected, that is positive side. So now I've connected both the diodes. I will show it to you once again. This is one AC. This is another AC. Okay, one AC, another AC. I've connected 2 points here, and this is negative. That is common point. This is negative point. Okay, please remember this. And I will nothing, no changes at all. Only 2 diodes and 3 connections from the transformer. Now I will try to switch on these things. You can see the light has come. Okay, the light has already come. Now I will check the voltage again. How to check the voltage? Again, I will go to the AC first, 200 volts. Here you have to check 2 voltages. Please remember. So negative, this 2 voltages means from the center tap transformer, whatever we have given connection, center tap transformer, I will connect to this one end of the AC. How much it is coming? Once again, please. 9.4. Another end, 9.5. So almost center tap means almost same now, right? So this was the AC. So all the 3 from ground to one AC, ground to another AC, right? Okay. Now we'll check the DC. I'll put it to 20 volts again. I will just connect to the negative point here. That is negative point because it is going to, this jumper is going here only. And the common point where I've connected both the cathodes. Okay. So I've just connected it here. Cathode, it is 12.82 approximately. Correct. Same voltage drop. It already checked that will be the same only. What is the only difference is, instead of half-wave rectification I have done, I have connected 2 diodes over here. 2 diodes, and the rectification is full-wave rectification now. It is full-wave rectification. Filter full-wave rectification every time better than the half-wave rectification, and full-wave rectification is better. Okay, then you have bridge rectification. The next circuit will do it bridge rectification. So we'll try to connect the bridge rectifier also, right? So this simple type of circuit you have to understand. You have to do it by yourself. You have to try to do it by yourself.